Hi, I'm Bob Tabor with LearnVisualStudio.net. We spent the first 9 lessons learning the absolute basics, and we were able to build a simple app. I mean, the Pet Sounds app it's a nice start, but it's a little bit limiting at the moment. I mean, we only have one category of sounds, animal sounds, and we only got 2 sounds, the quack and the meow. And I've got larger aspirations for the app that we're going to build here than just 2 sounds. What I'd like to do is to turn this into a more full-fledged soundboard app with multiple categories of sounds. Not just animals, but taunts and warnings and all kinds of different types of sounds. And maybe even a custom category where we can record our own sounds into the phone and then have them available for playback whenever we wanted to annoy our friends or our cube mates. Okay? So we need a good way to represent multiple categories of sounds, not just one category, but multiple categories inside of our app. And I'm willing to bet that there's at least one template that's available in Visual Studio that will help give us a good starting point to get us pretty close to what I have in my mind. So in this lesson, what I want to do is create a couple of different projects, and we'll throw these projects away, but I want to review 2 project templates available in Visual Studio to learn a little bit more about what they can do, and in so doing determine if there's a good fit between the built-in capabilities of that template and what I have envisioned in my mind for our new version of our soundboard app. So the game plan for this lesson is, first of all, we're going to create a sample Windows Phone Databound app project using the templates in Visual Studio. To discover the built-in functionality of that template, we're going to look at the code and discover how it accomplishes those features. And then we're going to repeat this process for a second project template called the Windows Phone Pivot App project template. Okay? So let's go ahead and get started. In Visual Studio, I'm going to go File, New, Project, and we'll want to make sure we're working with the C# Windows Phone templates, and we want to select the Windows Phone Databound app project template in the center area. Now, yes, we get a little description here off the right-hand side, but it's just a little reminder. We want to really dig in and understand how this thing works, see what it does, and so on, see it live in action. So I'm not going to give it a name because we're going to throw this away. We'll just leave the default Databound App 1 name and then click OK. And we're going to target the 8.0 version of the Windows Phone operating system. And after Visual Studio sets up our new project, what we'll want to do is immediately run the app just to see what functionality we get out of the box. And when we run the app, you can see that the main feature of this app is a list of items. We can scroll through the items and even tap on one of the items. Let's take a look at Let's take a look at one of the items. For example, this runtime 1. There's a large header for runtime 1, runtime 2, runtime 3, and then below each of them there's some smaller text, what I would call lorem ipsum text, some fake Latin, just as filler text that means nothing. When I click on one of them, you can see that we see that particular item full screen on a second page of our app. And you can see that there is this the title and then this second line of text which has the complete lorem ipsum. Okay, and it works for each of the items, and we can use the back button to go back and so on. Okay, great. So the real question is, what's making this work? I mean, what is this? Is this a control, or how are we seeing all of these items, and where does this data come from? So let's keep that in mind as we investigate the anatomy of this app. And I'm going to start here on the main page.xaml, and I'm going to scroll down to the content panel, and I see immediately that the content panel is filled with this control called a long list selector. And if we were to take a look at the attributes of the long list selector, you can see that it has an item source attribute that's set to a binding syntax, and we're binding to something called items. All right, and then we can see that there is an item template that's set to an instance of data template. And inside of this data template, there is a stack panel and 2 text blocks. Now, as I'm making selections here in the XAML, do you notice what's going on in the viewer off to the left-hand side? When I put my text my cursor inside of the text block here, you can see it puts a blue selection box around this design 1. And when I put my mouse cursor inside of text block, the second one here, it highlights the little text underneath of it. So what we have here is a template. Each item in a collection of items will be represented with this block of XAML. So we have, on screen here, a bunch of, like 6 of these items, just fake data, dummy data, but it gives us an idea that each instance of an object inside of a collection called items will get its own stack panel with 2 text blocks. So that's the notion of an item template, represented by this data template we've created here, or that's been created for us in the XAML. Okay. So the real question is, where is all this data coming from? Well, what we can do is, the simple way to go about this is just to take a look at this sample data folder. This would probably give us a nice clue since its name is sample data. And if we were to open this up into our main area here, you can see that we have an object called main view model, and it has an items property, and this items property seems to hold a collection of objects. Each of those objects are of type item view model. And notice the attributes of each instance of item view model. There's an ID attribute, a line 1 attribute, and a line 2 attribute. And notice that the names of line 1, line 2, line 3, line 4, they happen to match up with what we see here in our designer. Furthermore, line 2 for each of these objects match up with what we see in the smaller subtitle for each of these items. So that provides us a clue. We would expect to see somewhere defined a class named main view model, and that main view model class would have a bunch of attributes. One of the attributes would be an items attribute, a collection, maybe like a list of T, and the T would be item view model. So there must be another class defined in our project called item view model somewhere. So as I take a look through the folders of this app that this template, there is a view models folder, and if I open that up, whoa, notice that I get a main view model class. Whoa, that matches this. And an item view model class. And you think that it has something to do with this item view model here? Well, let's take a look at that real quick. ItemviewModel.cs. It's just a simple class, and it has a number of properties defined. Let's roll some things up here just to make it all nice and clean and obvious. All right. So this class has an ID property, a line 1 property, a line 2 property, and then a line 3 property. I don't think we're using that. And it also has some other stuff, and we'll talk about this other stuff in a little bit. But that is the item view model class. And we're creating instances of that item view model here in XAML and adding them to a collection called items. Now let's just go for broke here and take a look at this main view model class that should match this data that we have generated here, instances of those items in this XAML file. And notice that it has a property called, where are you, property? There you are. An items property of type observable collection of type item view model. All right, well, I've never seen, or you may have never seen, this observable collection class, but think of it for now like a list. Like we talked about generics and generic collections in the C# Fundamentals course on Channel 9. So just borrow that knowledge that you gained in that series, and if you don't remember it, then go back and watch those videos. But we have a collection of objects of a certain type, and that's what we have here, a collection of objects of a certain type. Every object in that collection has to be of type item view model. Okay? So that's our first clue. The second part is this iNotify property changed interface. And if we look at our other class, it also has this iNotify property changed interface. Well, what's that all about? Well, it has something to do with what we see below that here, with this event called property change event handler. And we're basically publishing an event that says, that will raise and will say, hey, I raised myself. Hey, I'm an event. If you're listening to me, I just fired off. Okay? So it's just a way of notifying other classes that might be looking at that class or might hold a reference to that class to say, something about me changed. So what this iNotifyProperty changed interface does is it enables this feature in .NET called observability. And it says, if you're looking at me, I can tell you when something about me changed. For example, if during the course of the execution of this application, some code changes the value of the line 2 property, changes it from its default that was set up during construction, this, in the setter of this property, it will say, hey, whatever your value is, notify that I changed. And so it will call this helper method called notifyPropertyChange. Notice we have that defined here. And it will in turn kick off this property changed event handler. So in other words, it works like this. If there's code that changes, for example, the line 2 property, the line 2 property will say in its setter, hey, let somebody know that I changed. And so it calls this method, which says, you changed? Okay, well then I better notify anybody who's looking at me. And so it raises it in a very public way and says, I changed. Hey, if you're listening to me, I changed. Okay? And so anything that's listening to that object will then say, oh, you changed? Then I need to do something. Well, what's listening to this object? Well, that's where this main view model class comes in. It too implements this iNotifyPropertyChanged interface, and it too has all that plumbing that we would see here at the very bottom. With it has a public event, and then it has this private notifyPropertyChanged helper method. But notice that it has this, again, observable collection. So this is observability. It says, if something about my collection of objects changed, if it says, hey, I changed, then I need to say, hey, I changed, as one of my objects that I'm holding a reference to, they changed. So if you're looking at me, you need to update yourself. So in the long list selector, I'm binding to main view model dot items so that if any of the instances of item view model change, I can say my collection changed, you need to update yourself, long list selector. Okay? So that in a nutshell is the notion of observability, and it's the foundation for this pattern called model view view model, or MVVM. Okay, so the important question is, why would any other code want to be notified about the changes going on inside of this collection? Well, as this example stands right now, there's absolutely no reason in the world why any other code would want to be notified, because all of this sample data here, it's all static. And from the way that the template is created, again, as it stands, nothing is changing the values inside of these instances of these properties, okay? And so what if, however, we wanted to support a new feature inside of this app where these individual list items were being updated constantly from some outside source? Say, for example, a web service. So the web service delivers new lorem ipsum every 30 seconds. Why? I don't know. Okay, and this doesn't make a whole lot of sense in this case, but it might be sports scores, or it might be news stories, or something else that needs to be updated every so often. But if that's the case, then, as silly as it might sound, if we added the code to dynamically change the data in each instance of these item view models, then that's the only thing that would need to change in our app. Every property would automatically be updated and say, hey, my value changed whenever we updated an instance of these objects. And the observable collection would report this to the long list selector, and then it would be automatically updated in our app on screen. Okay, so all of this extra code here that's used, implementing the iNotify property changed interface, and implementing this event and this private method, and all of the set code here that's generated. Again, it enables that feature called observability. So our soundboard app probably is not going to require observability, so I'm not going to implement all this extra code in our version of our app. However, if I had a good candidate for this style of application where my data could change often, then I would definitely take this approach that's been templated in this project. And the good news is that here's a nice template for you to use. You can just kind of fill in the blanks and add your own properties and make sure you follow this basic style of the sets and the gets, and everything should work just fine. Okay, so this long list selector is obviously using some sample data at design time, but what's going on at runtime? Is it using this data at runtime? Well, as we'll see in a moment, we're not. Take a look at what happens whenever we run the app. In the app.xaml.cs file, you can see that we create a property called viewModel. And so this viewModel property will be global to the entire app. All we need to do from anywhere in our C# code is just called app, because it's a global object in our Windows Phone apps. So app.viewModel. And when we do that, we will return an instance of viewModel. If a viewModel instance is not already created, then we'll set it to a new instance of our main viewModel. In other words, this topmost object in our object hierarchy that holds, through its items collection, a number of item viewModel instances, right? And then whenever here in the application activated event handler, so when the app first loads and when it's first activated, it'll say, hey, app viewModel, are you loaded? Do you have your data loaded? So let's take a look at the main viewModel.cs. And you'll see this is data loaded. It's basically just a Boolean flag, true or false. Yes, I have data loaded. No, I don't have data loaded. If you don't have data loaded, then go ahead and load your data. All right, so let's take a look at the main viewModel. Is there a public method called load data? Oh, there is a public method called load data. And look at what it does. It uses it's adding items to its items collection that it defined here, this observable collection of item viewModel. So it's creating new instances of item viewModel, setting its ID, its line 1 and its line 2 at runtime to these instances. So that's where the data is coming from at runtime. This is where the data is coming from at design time. And that's why it's defined in this XAML file, because as we'll see a little bit later, if you look at the very top, you'll see that at design data, it's binding to sample data / main view model sample data.xaml. That's what gives us this design time experience in Blend or in Visual Studio. But at runtime, we're actually generating the data here, and then we say, yep, data's loaded now, we're ready to go. So if you wanted to replace where you're loading your data from, you would do it here in this load data method, okay? You could modify this to retrieve data from a web service or from a local database or from a different XML file. One more thing, this takes care of the case where we're activating the app for the first time. What about the case where we're navigating away from the app and then coming back to it at some point in time? In that case, you'll take a look at the main page.xaml.cs. It has almost the identical code in it. So in the onNavigated_to event, so we've navigated to our main page.xaml. Is your data loaded? Yes or no? Oh, no, I don't have data loaded. Okay, well then go ahead and load your data. Oh, no, I have data loaded. Okay, well then ignore that. All right, that's what this is doing right here. And it's just using, again, main view model.cs, its load data method, and its is data loaded method to determine whether it should load data or not. Okay, there we go. All right, so hopefully at a high level, you can see how the Windows Phone Databound app template is wired up to enable data access through a pattern called MVVM, utilizing features in C# and the Windows Phone runtime called observability. You'll want to keep that in mind because that's a popular pattern whenever you're working with XAML code in Windows Presentation Foundation apps, in Windows 8 App Store apps, and then obviously here on the phone. Okay. So while the data binding project, here let's run it real quick, it does accommodate several features that we want implemented in our soundboard app. I mean, we want to be able to have individual items, and we want to be able to click on one and play a sound. We still need a way to navigate between different categories of sounds. Right now we would only have like one category. Imagine we'll replace page name with animals. How do we get to warnings and taunts and other sound effects? Well, there's no easy way to navigate between them. So, tell you what we're going to do. With that in mind, let's stop this, and we're going to go File, New Project, and this time we're going to select the Windows Phone Pivot App template. And we're going to leave the name alone, and we're going to click OK. Okay, and we'll go ahead and make sure that we're targeting version 8 of the operating system. And so immediately what we want to do is run the app and see what it'll do without any modifications. This looks a little bit more like what we're interested in, right? Here are all the individual items. Now, if you click on them, they don't do anything. That's just because it's been disabled, but we can get that functionality back. But more importantly now, in addition to having each of the individual items that we can click on, we have these categories of items. So we're able to now go between a first listing and a second listing, and this is exactly what I'm looking for. Okay. Admittedly, it looks like we're working with sample data, and the long list selector is data bound to the same list, no matter whether I choose first or second. But the idea here is that we can create a pivot that has multiple pivot item elements. So here's the first pivot item element and the second pivot item element, what I may have referred to as a view or a page or something like that a moment ago. And each of those will contain a long list selector that's bound to, ideally, different data. So let's take a look at how this is implemented in our XAML code. Here again, we're going to take a look at our content panel. Oh, there is no content panel. Instead, what we have is a pivot control. And the pivot control has a title called My Application. So this is going to take up the entire space of our layout route. All right, and notice that there are a number of pivot items. The first pivot item has the header of first, and the second pivot item has the header of second. Each pivot item has a long list selector. The long list selector has its item source set to bind to an items collection, and the property element syntax for each item template is set to an instance of data template, the same stack panel and text blocks that we saw previously in the Databound app template. If we were to look at the sample data, it also sports this main view model sample data.xaml. We can see that it defines this object hierarchy of main view model, which has a collection of items, and each of the items are instances of item view model. And if we take a look at the view models folder, it too has a main view model class and an item view model class. If you were to look at these are identical to what we saw before. Okay, so the good news here is that we're familiar with almost everything that's already here from this point on. The main difference here is the pivot control that has a number of pivot items, and each of those have long list selectors that we bind to. All right, so we could use the Windows Phone Pivot App template to create categories of sounds, and each sound would be rendered based on its data template. And we could create a data model that would have categories that contain collections of sounds, including information like the name of the sound, the path to the wave file that will be played in the media player. And so the good news is that we have a clear direction now for what needs to happen next. What remains is just implementation details, and we'll do that in the next several videos. So to recap, in this lesson, we learned about the features of the Windows Phone project templates, the Databound template and the Pivot template, and they share almost identical features. They both data bind a long list selector to a data model that's populated with data at design time from an XML file and at runtime inside of our main view model.cs load data method. All right, and not only is the data bound to controls inside of a data template like we see here, but the templates provide a pattern for monitoring changes to the underlying data and automatically updating the user interface as those changes are made. Now, we're not going to need that feature in our projects, but it's nice to know that it's there and that it's a simple pattern that we can use in these project templates should we ever need it. And then finally, we saw the use of the pivot control and how to create individual pivot items in order to allow us to move between categories of sounds. Awesome. All right, so let's pick up that thought in the next lesson, and then we'll begin building our soundboard app that we'll submit to the store. We'll see you there. Thank you.